Good afternoon, everyone. I think you had a very good meal, it seems. So, was it good or how do you feel? Was it better than your office food? Let's say. So, we are going to talk about WebAssembly. I'm going to ask some 2-3 questions to get the idea of where we are and how do we go about this presentation. So, anyone heard about WebAssembly before or studied about it? What do you think about JavaScript? So, let's say it's all good and great. We are doing a lot of great things in that one. So, anybody has a problem with JavaScript? Let's say core fan of some system programming or Java, C. So, this is where it's like you want to do web application development, but you are a very big fan of some system programming language or Java and stuff. This is where WebAssembly is the great starting point to do all those things. So, we will talk about how JavaScript and browser evolution, how it came from like 1995 to 2018, how it traveled in 1 or 2 slides, and then we'll see about how JavaScript works in our browser actually, and what WebAssembly is bringing, what is WebAssembly are called as WASM, and what it is bringing to the developer or user, and then why it is awesome. So, let's say we are saying like it's great and all, so why it is awesome and all those things, we'll look into that one. So, initially JavaScript was launched by Netscape, and they launched in their 2.0 version of browser release, and it was great at that time. So, before what we were writing is completely static page. You take HTML and add some CSS and that's it. So, if you have 1000 screens, then probably we had 1000 files, HTML files, and then JavaScript came in and it brought a dynamism to the static pages. So, we started doing a lot of single page applications, all those things. Over the time it evolved. So, to improve the performance or to improve the web page rendering faster, browsers and some communities, some companies started adding support from the other languages. Java plugins, applets were there. They were ridiculously slow, but it was good at that time. And then IE brought ActiveX, which does some performance tuning at the browser IE level. Similar to that, Flash came, and then HTML5 was the main transformation which we got in static pages, where before to play video, audio and all, we were relied on JavaScript, but HTML5 really brought those things to the core. So, that was easier even in terms of performance. And then modern JS engines. So, from 2008 onwards, like you can see the curve, right? So, when JavaScript came initially, that performance was and popularity was like, it was good compared to static pages, it was good, but it really took off when browsers added JIT compilation. So, just in time compilation based on your code and all those things. We will talk about more about JIT, how it works at the browser level. So, these are the, and recently ASM.js. Anyone heard about ASM.js? So, it's let's say older brother of WebAssembly. So, these are like aggressive optimization they made in ASM.js. So, you will write your code and compile it to ASM.js compatible one, and that performance improvement was very good. So, till 2017 it was good everything, but as we see in a trend, IT trend, we got so much facilities. So, we started building very big applications. Now, with the JIT also we are like, okay, it's slower, we need to do some performance tuning, all those things. So, where we will go from 2017, and that's where WebAssembly came into picture. And so, next that we will talk about WebAssembly. Then JavaScript strengths are, why everybody loves JavaScript. It's a dynamic typing, so you don't have to worry about whether my variable will be a string or integer. So, it kind of a drawback for some extent, but it was good. So, it's interpreted, you just go to browser console and type a code, it works. So if you want to do same one line of code in Java, it takes a lot of time to set up and all installing all those things. So that way interpreted languages are very good to get started, but when you really scale, then you will see the performance problems. So easy to learn. So everybody is familiar with other language syntax, so it's almost similar to Java, but it's easier to learn in a way. So then executes in browser environment. So every OS is shipped with one or the other browser. So that way you can execute your JavaScript files in a browser. And DOM manipulation. So bringing dynamic content addition, all those things to HTML was really good. So what does JavaScript lack? So everybody might have faced in any one of the phase where you are doing JavaScript development and you want to increase the performance. So nowadays statistics says that within 3 milliseconds, if your page is not loading, the user might leave your website. So if you are like customer centric application, then you are really into that performance mode where you want to load everything and work smoother way. So that's where performance is lacking in JavaScript. We will discuss about that, why it is lacking and what is the process that browser is taking to do that, and why it is lacking in terms of speed. And access to OS features. Only browsers provide some certain web APIs, only using those you can access OS information, but you can do a lot of things like for example C, you can work at system level to do resource management, all those things. Here you don't have permission, or we cannot do it first of all. So we are relying on browser and JavaScript engine which is shipping with that one. So in that case, so this is how browser executes the JavaScript. So any JavaScript code you take, what it happens, the parser will first go through the JavaScript syntax. JavaScript compiler has certain conditions to execute a JavaScript file. So it will first parse it and build a abstract syntax tree which is understandable by JavaScript compiler, and then it will generate the bytecode out of it, and then that bytecode, this is where JIT compiler is coming. So JIT part will execute whenever your interpreter is executing your JavaScript code. JIT compiler is actually monitoring and profiling your code, and it is storing certain repeated codes in let me go back and explain it a little bit deeper. So in JIT it comes with like 2 compilers. So one is, it is a one compiler, but it has 2 sections. One is base compiler and another one is optimization compiler. So what base compiler does is, it when in profiling section, it will observe and profile your code. Is any code is repeating or running more than once. For example, for loop, if it is certain syntax within the for loop is running continuously based on the condition. So whenever base compiler sees those kind of code, those bytecode are stored in the index DB. Index DB is a browser's internal DB. Every browser has its own DB. How it stores, it's up to the browser implementation, but it stores those bytecode in that one, and whenever this code comes, instead of parsing and generating the code once again, it uses this bytecode and runs it. So this is where our performance tuning is happening. So in modern browsers, why it is faster compared to older one is, so this JIT compiler does that job. So initially 1 or 2 times it may not do the optimization, but if it is running more than 2-3 times, it will profile it and store that bytecode and runs it. So full JIT compiler where optimization comes. So this certain type of code is stored already, and it is moving back and forth between interpreter running time and storing in the DB. But certain codes are like, we can improve even more. So you can store it for longer time, and same kind of code is repeated in some other pages, you can use it. That's where full JIT compiler will does this transformation. Garbage collector, at last it will collect, means clean up the memory whatever used one. So these are the stages, like it will parse it and it will compile and optimize it, then optimized compilers will come and they will re-optimize the code if it necessary, and then it will execute, and then garbage collection will takes care of the things. So this is the time for any line of code, JavaScript code we are shipping. This is the process it goes through, and this has some time. It will take some time to do all those things. So what are the current solutions we are coming up with this one? I'm talking only about JavaScript. So we have some frameworks which does the optimization for us and writes the better JavaScript transformation instead of whatever we are writing, that one. So minification. So in web application there are two problems always: shipping your code to browser and executing it. These are the main two areas which has some delay. So shipping we can do by minification. In current days we are doing by minification. We are shipping it a smaller size, so it loads faster, and then we are executing all those things. So in a recent Angular, React and Vue.js, they have their own packers. So Webpack and all, they are doing some transformation to your JavaScript code to make it optimized, which runs faster. So these are all not good solutions, right? So whatever we are doing here, we are solving only half of the problem, but actual problem at the execution level where it takes time. So that's where WebAssembly comes into picture. It's a bytecode, new type of low level language which browser engine understands and executes at machine level, but it's near native. Almost, let's say your native program runs at 1x speed. This WASM code runs at 1.2, which is far better than JavaScript code. So it is not actually a bytecode, machine readable code, but it is a bytecode which is written in ASM.js format. So initially Google came up with the native client concept. They were building themselves to put it into Chrome. What does that is, we have seen that slide where we have a parsing and compiling and all, right? So that re-optimization phase, whatever code is there, this WASM will generate that code directly. So we are saving lots of parsing time and compile time. So it's already compiled code and you are just going to execute that at level. So it is developed by W3C group, and they made it a 1.0 minimal viable product release in this year, March. So, and then there, since November 2017, all browsers are supporting. It's not like every time we were seeing like Chrome is releasing all new features, Firefox is doing, but we were never really get those features from Internet Explorer, Microsoft. But this time they are also on board, and all major browsers, Safari, Internet Explorer, everybody has Internet Explorer means Edge. So IE11 is not supporting. So all four companies came together, they deprecated their own internal projects to do same job, and everybody is coming together and building this WebAssembly. So history wise, 2015 it started, and at that time already Google has its own native client project, and Microsoft has its own ASM.js project, and then Mozilla started WebAssembly with the name, and then they came together and they said like, okay, so everybody is building same thing in different format, but each one has its own transpiler to compile the code. So they came together and built as a WebAssembly, and they deprecated their own old projects. So now it's default in all the browsers. You can generate your WebAssembly code and execute in your browser directly. So now almost all the browsers except Opera, I think, are supporting that one. So why WebAssembly? So these are the three languages: C, C++, and Rust. They are supporting from the initial days, and it works fully compatible with 1.0 WebAssembly release. So whatever WebAssembly spec says, these languages can compile to that bytecode. So Rust has especially Rust, that Rust compiler has its own homegrown support. So to run the C, C++ to WebAssembly, you need to install mscripton and all. Those are listed in the next slide. So in Rust, it supports out of the box. It has a target code, commands which executes your Rust program and builds the WebAssembly bytecode. So binary format. So Let's say we have a thousand lines of JavaScript code, and that file to ship that one. So based on your developer, so human readability, code readability is the main thing we ask for developers to do in organizations. So when you are doing a readable code, you are using really big strings to specify and give the context to each function and methods. So can you imagine like 1,000 lines of JavaScript code, which is very designed way. So how much size it will take and how much shipping time to browser. So same way, if you generate a WebAssembly out of same code, so it's very smaller because you are all the code is in terms of hex code. So that size is drastically reduced, and even in 2G speed, I think it's blazingly faster to load the WebAssembly. So and supports integration with JS. So this is the main feature they are trying to keep from the initial days. So all JavaScript functions should be able to call the WebAssembly code. So in WebAssembly, you need to expose in certain way to talk to JavaScript, but all the browsers can talk to WebAssembly code, and WebAssembly code can talk to JavaScript code. So that way interoperability is seamless. So even certain part of your code application can be written in WebAssembly and half of them in JavaScript, and they seem to work together very nicely. So close IR of the JS engines. So JS engines know how to process your WebAssembly code. So that way interoperability between those two are very good, and WASM is faster than JavaScript. So any JavaScript which does calculation, it takes up the CPU memory, and it doesn't have a very good memory management and all those things. So JavaScript is run through browsers, so doing CPU intensive tasks are really difficult, and that is error prone also, so because of its dynamicity. So WASM brings those all powers to your browser, and you can run it with a near native speed. So actually it's a high level 1.2x they are saying. So if a really very good transpiler can do almost native speed, native code speed. So how browser executes WASM? So before we saw like JavaScript does the parsing, but in WASM there is no parsing because you are already generated a bytecode which browser engine understands, and we are passing that. So we are encoding it. So to do some error correcting codes and all to have that feature. So there may be encoded by some compilers, but decoding is very easiest job for JavaScript engine, and all those compile and optimization. Compiling happens at lower level, so machine code. So there are two levels, right? So your JavaScript code is converted to bytecode, then bytecode is converted to machine code, zeros and ones. So we already got bytecode, and converting it to machine code takes same time as JavaScript takes, but that is very minimal time. So it's ignorable, and then it executes. Execution speed also is like it runs in its own sandboxed environment. So all WebAssembly code doesn't run through same JavaScript event management system. It creates a separate sandboxed environment within browser and executes there. So that way we are not interrupting with any HTML events, anything that browser does, but it is running separately. So the execution speed is very smaller, very high, and the time taken to execute and memory utilization, everything is very smaller. So where can we use this? The major usages today we are seeing in video games. So online video games are crappy before, like for 3-4 years back, but who were developing an online video game, that was really very minimalistic level. So you are not getting that graphics and all those speed, all those things. But with this WebAssembly, you can ship your whole application as a WebAssembly, and just one script can trigger that one, and you can do a lot of cool stuff in browser. So at last we will see a demo of some of the games and video editing softwares which Unity and Mozilla did. Those are all really cool stuff. So and image and video editing. So any software. So you are editing, like manipulation of video, audio, or anything which takes CPU time. Like CPU intensive tasks are really bad in JavaScript. So running that through browser and accessing all those things. Let's go through the list. So you get the idea, right? So wherever JavaScript was lacking performance-wise, CPU intensive tasks, where were you doing calculations and all, there you can use this WebAssembly with the same technology stack. Only thing is whatever existing code. So like you have written in C or Rust or in future Java or .NET, all those things are supported in WebAssembly. So you can use it in mobile devices. So anybody is developing hybrid applications using front-end technologies, they know the pain of running mobile application in smaller specs. So there you can take advantage of WebAssembly to do very minimal resource usage and all those things, optimizations for your app. So why is it awesome? Because it's faster. So it's imagine that you have like a very bigger spec machine and you are running in near native speed. So nowadays anybody is using laptops, they are almost like 2 GB RAM. Minimal spec is 2 GB RAM and 2 GHz processor. So you can take advantage of those speed in your application. So and languages are generated by, so you are not writing any WebAssembly code directly, so they are generated by some other compiler. So you are just writing your actual business code in your chosen language and you are compiling it to browser specific. So that way, and WebAssembly is memory safe. Security wise it's good compared to JavaScript. In JavaScript we see XSS attacks and all those things, CSRF attacks. You will never face this because nobody can understand the bytecode and manipulate it to do however they want, because it's not human readable. To parse that also they should know what compiler they used and all. So that way taking over your code is a really big problem for attacker, but for you it's a better one. So that way memory safe and it's running in sandboxed environment. Any drawbacks like security wise that is coming, like memory leaks and all those things, you should take care of it in your chosen language. That is the one drawback we have. And reuse of algorithms from server side in game development and all those things. So these are the compilers available: LLVM, WASM, Binarian, ASM2 WASM, Mscript, and these are the major compilers who support C and C++ compilations. So proficient in Rust. Rust is a fairly new language, system level language. So if you are choosing Rust as your main WebAssembly program, then you can use that one because Rust has a compile level support. So can we use WebAssembly today? Yes, because major browsers all are shipped already and it's stable one, and W3C also has major like 1.0 release, so they are made it stable. So what are the future? So their WebAssembly team is working on making even more performant in browsers. Currently talking to JavaScript to WebAssembly code and WebAssembly code to JavaScript is taking little bit of time. It's not as seamless as they expected. So in the next release they are going to work on those things and loading the bytecode into your system and creating a sandbox environment in your browser. All those improvements they are bringing the spec for that, and all the browsers are in line to do implementation of that one. And WebAssembly today it cannot do DOM manipulation, so that one they are bringing in next release. So same way, shared memory concurrency. So JavaScript has a shared array buffer, which is a shared memory between JavaScript threads. That one also is supported, will be supported in future. So all these other things, garbage collection is mainly for compile time applications. So that one also will come in the next release. So some cool stuffs. So I think we are lack of time. I may not be able to demo it, but these are the websites you can visit and see how WebAssembly, they have a comparison in the corner, like JavaScript how much time it takes and WebAssembly how much time it takes. So you can really see the difference and improvements in that one. So thank you.
Is it not that WebAssembly has come again or bringing us into an era when it was ActiveX, which was a binary code which has been released to browser, and how secure it will be? Because the way binary which has come earlier, be it Flash or be it ActiveX, there used to be a, the code is not known to you what that code is doing it, and there used to be lots of security issues.
Yeah.
How WebAssembly is trying to take care of that part?
So yeah, I will. Yeah. So this is the game which is hosted in WebAssembly homepage. So Unity company built this game using only WebAssembly. So they implemented their game in C language, but they are loading it in browser, and there is no delay actually. So you can see all the features of browser like zooming and all those things. If you wanna do in your JavaScript based one, zooming and all are easy, but the lag between movement of the object within your browser window and repainting the whole HTML was really bad. So we could see that lag time in the view. So this is one of the example. And to answer your question, so ActiveX was a plugin to browser. There is a significant design difference between these two. So ActiveX plugin, you need to install it in your browser, or later time they were loading that whole compiler to browser. So here you are all in your development machine or in your let's say development machine or anywhere, you are already generating a bytecode out of it. So you are only shipping the bytecode, and all the memory management, everything is within this. So whenever you are using ActiveX, you are loading that plugin to browser, then you are sending your code to browser. There it was doing compilation, then it was generating bytecode and executing. But in WebAssembly, all this process you are doing offline within your home or office comfortably, and only bytecode you are shipping. So while shipping also, you can take advantage of Webpack, all those bundlers to minify it and compress it and ship it to browser. Once it's in browser, once it is invoked, it runs in sandboxed environment. So any memory leaks or any problems you face, that is only because we did a bad coding in the native language whichever we used. So if you are using C and we did some memory leaks, and because of that it is causing problem or security issues, that's really our code problem, not the WebAssembly part of it. So that way it's a.
But for example, right now, if I have a issue in writing JavaScript which might create a memory leak or something, it does not make my customers browser or machine compromise. But if you're talking about a C or memory leak which happens into a browser, it can lead to customers' machine getting infected. So how does WebAssembly try to tackle this type of issues of a memory leak?
Yeah, in a next release they are bringing this one, but the thing is, when you see at WebAssembly as a only WebAssembly part, so the entry point is already generated code. So any memory leaks is that source problem, right? So WebAssembly can't do. You are allocating some 10 bytes of memory, 100,000 bytes of array in your memory and not using it and blocking it to access by other resources, then it's really our program problem. So that way WebAssembly doesn't help you there, but it is running in one thing which is not going to cause a problem to customer, because it's running in sandboxed environment within browser. So whatever memory leaks this WebAssembly code did, so once it sends, and browser will take care of cleaning up whole thing. So today whenever you use web workers or service workers, that is what's happening, right? Browser is taking care of the ownership and running it in separate thread and cleaning up all those things. So same way it happens. So that way WebAssembly as a security threat might not be there, but yes, it's probable because of other issues.
Of the versions available, which one would you rate best and user friendly? Like WASM, binary n, etc. Which one is the best one?
So it really depends on which language you are choosing. So LLVM is the main supporter of all system programs also. And mscripton is the matured one, so it knows all the type of problems like threading, all those things which you handle in C code. How to translate that mscripton is matured one, and it was like taken as a base even by W3C, whoever is writing the WebAssembly spec. They were actually implementing those in mscripton and trying out. So mscripton is really matured one. And if you choose Rust, it has language support. You can compile your application to target the WebAssembly code. So that way, mscripton is the best one. You can try it.
So does it mean that the application, for example, I have a C-based GUI application developed that can be converted into WebAssembly that can be deployed in the browser?
Yeah, so if it is a C-based GUI application, I think a presentation layer has to be handled by once again JavaScript, because WebAssembly right now in this 1.0 release doesn't have a support for DOM manipulation. So we can do only CPU related calculation, business logic related stuff. So
okay. And are there any restrictions? So like for example, no, in C I can do anything, right? I can interact with OS, anything. Right? Same thing is possible here.
Yes.
If that is the case, that means indirectly customers, client resources are being used by this application, even
yes.
without the customer knowing it, client knowing it.
That might be possible. So currently already blockchain guys are taking advantage of that and doing cryptocurrency mining. So that way browsers are bringing security restrictions. So that way I think it's not up to there to block all illegal stuff. So hopefully that will be taken care by next release.
In fact, I think one of the limitations you mentioned initially, JavaScript has certain limitations. What it can do on the browser client machine was done purposely, right? It was done purposely to restrict access to client resources.
I agree and disagree. So it was not purposeful, but the target when they started JavaScript was different. So their focus was different. So that way they never focused on this part. In Node.js they started it, and in Node.js you can access whole resources of the machine, right? So that way when browsers are shipping, their target is to run that in the environment, browser environment, not to access the resources and all. But with V8 engine or any JavaScript engine, you can actually access the CPU through other mechanism. If you host your let's say V8 engine in Google Chrome, that is used by Node.js. So instead of Node.js, you can take that engine and run in your own environment. You can still access the resources. So that way.
See, normal C program.
Yes, it has access
to the client machine, right?
So WebAssembly is targeted to take advantage of those resources. So we have lots of CPU, and you want to play an online game instead of installing in your system. So to do that in JavaScript, it was really bad from a user experience point of view, and even running that through browser is like really difficult. So now you can take advantage of all the available resources and all, like CPU, RAM and all, and you can run it within your browser. So that way it's advantage.
So it's also not OS specific, like the browser Chrome is available in mobile or Android or this one?
Yes, in the support, if that browser is supporting in all platforms, it works in all platforms. So that way.
Thank you.